Alright, this is continuing on with domain and range. In this video, I'm just going to tell you or show you how to find the domain from an equation. Okay, so remember again to review, domain are the x values, the values that you can plug in for x in that equation. And in general, it's really simple when you're given an equation. If we could graph it, you could see the previous video, but if we can't graph it, we can still do the domain. We just pretty much always say it's all real numbers. Okay. Remember, in interval notation, all real numbers is expressed as everything from negative infinity to positive infinity. Okay. There are two exceptions or things you have to watch out for. When we're determining domain, we've got to make sure any x we plug in doesn't cause us to take the square root of a negative number. That means all of our radicands, things under the radical, have to be positive. So we've got to watch out for that. Radicals. And the second thing is we've got to make sure we never divide by 0. So we can't plug in an x that causes division by 0. So we're looking for radicals and we're looking for division by 0. Otherwise, it's all real numbers. So let's take a look at the first problem I have set up here. This is an equation. This happens to be the equation of a line, which is a function. So quite frequently, this would be written in function notation, like so. And as I look at it, I'm like, well, there's no radical in it, and I'm not dividing by 0. There's no x even in the denominator. This x that is in the equation, it's written right next to the fraction bar, which means it's in the numerator. So no x could make my denominator 0, causing me to divide by 0. So my domain is all real numbers, negative infinity to and positive infinity. If you were to graph this thing, make a quick sketch of it, it's got a y-intercept of 5, 3, 4, 5. It's got a slope of down 3 over 2. It look like this. It's just a line. Goes left and right forever. It goes up and down too, but it also goes left and right. And so our domain, every real number. That's all there is to it. Next equation. This also is a function. You could graph it and run the vertical line test on it if you wanted to see. Okay. Different problem though, because this last one had no radicals in it, but this one does have a big radical. In fact, it is equal to the square root of 3x plus 4. Okay, and if you have a radical, you have to guarantee that this stuff, the radicand, 3x plus 4, is greater than or equal to 0. Well, how do you find that out? You just take 3x plus 4 and you say, hey, you have got to be greater than 0. And when we solve this, it tells us what numbers x can be so that that happens. And it turns out, as long as x is bigger than or equal to negative 4/3, that this number under the radical will be positive, or 0, and I can take the square root of a positive or a 0. And so my domain is just what this equation told me. It's everything greater than negative 4/3, including the negative 4/3. So it looks like that. Everything bigger than negative 4/3 all the way to infinity will work. And just to show you why we do this, or if I just said all real numbers, let me show you something that didn't work. X equals 0. 0 is not in that range or in that interval. 0 is in that interval. Let's show you that 0 works. If I plug a 0 into the function f of 0, I get 3 times 0 plus 4. I get the square root of 4, which is 2. 0 is in the interval. 0 worked. Now choose something not in the not in the interval, like negative 2. If I plug in negative 2, I get the square root. 3 times negative 2 plus 4. It's negative 6 plus 4. I get the square root of negative 2, and that is not possible. So it's only when I stick in values for x that are bigger than negative 4/3 that this equation has any meaning. And so that's what I have to limit my domain to. Just plug in numbers greater than or equal to negative 4/3. Next one. Again, it looks like I probably have a function here, f of x was 3 over 4x minus 1, so that would be another way you might see this. Again, I always start off with all real numbers for my domain unless I see a variable or a radical and that variable is in a denominator. And look at that x. It's in the bottom, it's in a fraction. Okay? So if I plug in the wrong x, that denominator could become 0, and then 3 divided by 0 is undefined. I can't do the math any longer. So I got to make sure that never happens. So I first find out, hey, 4x minus 1, what makes you 0? And I solve that. I add 1 to both sides and divide by 4. And it says, hey, if x is 1/4, the denominator is 0, and the equation falls apart. So my domain, I still say it's everything from negative infinity to positive infinity, but I say I am going to exclude 1/4. And so I just put negative infinity to positive, all real numbers, but x does not equal 1/4. Yeah, you can actually see if I plug in 1/4 into the equation, I get 3 over 4 times 1/4 minus 1, 3 over 1 minus 1, 3 over 0 undefined. And that's why I have to include that statement as part of my domain. Last one. In this one, I've got two things going on. I've got a radical, and I've got a variable in the denominator. So I've got to watch out for division by 0. Again, I say, okay, stuff under the radical, you have got to be greater than 0. Now notice I was very careful here. I just used the greater than symbol. I didn't put greater than or equal to 0. The reason I did that is because even if 3x minus 1 is 0, I can square root of 0. But if 3x minus 1 equaled 0, the denominator would be 0, and I can't divide by a 0. So in this case, I want to use this weak inequality or strong inequality that says, hey, you got to be bigger than 0. You cannot be equal to it. So 3x is greater than 1. X has got to be bigger than 1/3 in order for me to plug it in to that equation. Anything less than 1/3, I'm going to divide by either get an imaginary number, or if I plug in 1/3, I'm going to be dividing by 0. And so my domain is going to be everybody bigger than 1/3, not including the 1/3. So I use a paren on the 1/3 saying do not include it in your domain. And I think that is it. Hopefully that will help some of you who miss class or are having difficulties.